Okay. Hello everyone. Well, I guess it's time to try to start building this thing. You remember this from the first video where I asked the question if anybody'd like to build one. This I kind of started taking parts and redrawing schematics, so I've had to kind of extract the chassis and stuff out of it to look it over. Because when I originally built these, I just built them from what was in my head. And when I got one running the first time, I just copied it. And I'd never bothered to sit down and create a good schematic for it. I kind of had a couple drawings for the different stages, because I had a couple different ways I was trying to make them work. We're going to go in a slightly different direction. This flat chassis is just what I had when I had a stack of these things. They're old computer, some kind of a that was probably an early, I don't know if you'd call it a modem. It was like a distribution box. It ran several LAN systems off of this, and it had circuit boards in it. Anyhow, it was convenient to build stuff in. So what I'm going to do is go in a slightly different direction. Same circuit. A couple ideas, because there's been some technology developed since I made this that'll make things go just a little bit easier. Okay. Now, out with that. This is what let me make sure my viewfinder, or you can see this. Hope that isn't glaring too bright there. Now you're looking straight down into the chassis. The front panel. There's the front panel. This is the transverter, which you're going to be looking at, going to be building. You can use whatever layout suits you. If you need guidance on the layout, I can help with that. Just let me know. I'm going to build this one stage at a time, so that you'll be able to test it, see if the stage works, and you can relate to me if you have any problems with it, and I can guide you through maybe what you've done wrong, or to maybe a wiring change here and there. Okay, this is the schematic. This is the receive circuit. Now this doesn't have all the relays. I've tried to keep this as simple as possible. We'll get to them later, because there is some switching involved, because you got to change your antenna and your input and output to the CB radio. The little device, or the technology that I was talking about, is what's called a TCXO. And I bet I've misplaced the one I was going to show you. No, here it is. Okay. Yeah, right here. That little guy is the TCXO. Real simple. It uses 5 volts. It's a crystal oscillator, and you can get them off of eBay for around $3 or $4 a piece. And the one you want is a 20 megahertz. If you're going to build this exactly as I showed. I'm making this one so that it'll come out on the 40 meter band, or 7 megahertz 40 meter band. So let's say you got your CB radio and it's on channel 23, which is 27.255. That's going to come out on 7.255. Just as simple as that. This little device and the circuit gets rid of 20 megacycles to where you're going to be right down at 7.255. It runs on 5 volts, uses a Zener diode. It's going to run off of a 12 volt supply. It'll be a resistor. I'll show you all this later when we get to it. But to keep things simple, this is what you're going to build right now. One tube. We'll just, like I said, we'll deal with this one stage at a time. This is the RF amp. In other words, this end hooks to the antenna, gets tuned by a coil. There's a tuning cap on the front panel that's here, and a tuning cap on the output, the plate circuit, that's right here. And that's, if I can show them, that's these two right here. This is the underside as I have it right now. This filament, the orange one here, this wire here is the filament lead that I've tested this one, got it to work. And the two coils that's involved with this build is all just these parts right here. It's just that simple. There isn't very many parts. This is the RF gain pot. I'll show you that. It's right here. It's a 5K pot, panel mounted. And you can use a 12AU6 if you want to use 12 volt filament. I've used a 6AU6 just because I had them available. I've got lots of them around, and it was just something easy to use, and I tested it. It gives good, really good gain, and it works great with the coils as I've shown. And the coils are simply 35 turns of 30 gauge wire, a 1/4 inch diameter. That's what's on this one here. Is quite, this is a different coil for another part of the circuit, but I don't know if you can see. Yeah, you might be able to get that wire out of the way. This is the coil I'm talking about. These here, 35 turns of 30 gauge wire. And the slug tuned coil I'm using, I'm not sure where they came from, but they're a little cardboard form with a little snap-in type mount. You can use whatever you can find available that'll fit that. Some of them have a ceramic form with like a threaded thing. Those would be easy. And a lot of the military stuff, if you can find some good military surplus, you can probably pull some coils out of them. You can use 3/8 diameter, but you're going to have to maybe use a few less turns. It won't take as many turns if you use a 3/8 diameter form. But slug tuning helps, because once you get it to go and you've got your caps to tune it, you might need to adjust the slug in or out to make the tuning caps kind of fall in the center of their range. And you see it's kind of where I've got them. If you can see, they're about half mesh. I don't know if that camera picks that up or not, but they're just about half mesh. They're not fully meshed all the way, and that's where you want it. You're right about in the middle, and that allows you to go up and down the 40 meter band. Okay, like I say, it's pretty simple. You'll need a 150 volt supply. That's a transformer that has 120 volt in, 120 volt out, and just simply take a full wave bridge. I've addressed how to use those transformers in some earlier videos. You might go back and check them. I gave a couple of different examples, even some sources to find the transformers. Most of those are around $9–10 for the transformer, and a full wave bridge with some 1N 1004s and maybe 100 to 200 microfarads of capacitance should give you a nice clean 150 volts DC or so. It doesn't matter if it's exactly 150. This circuit will work on anything from 120 all the way up to 180, 190 volts. Just fine. Okay, so what I'm going to do is end this video here, and I will go on and create and wire up the next segment of that. That'll be this part here, the mixer circuit. It's going to be a 6BE6, and that's where I'll hook in the crystal oscillator for the injection oscillator, and this is going to convert our 7 megacycles in, and it's going to put it to a CB at on 27 megs. It'll boost it 27 megs, so you can use the CB radio to receive this. And I'll be back on the next video, and I'll break this down to where it's just this circuit here. So once you get this one done, then you'll be able to follow on and go to the next one. If you're unsure about the coils and how to tune them, how to find out what their resonant point is, check my videos out on the Q meter. I show how to build a Q meter, and it's a signal source and a measurement device that allows you to see where these coils are resonant at. And if you pick up one of them little frequency counters, they're for about $16, that'll help you nail it just exactly on the 7 megs. You're going to want to tune it to between 7 and 7.2 megahertz. It's right about where you're going to land the signal at. And once you get them tuned to that point, then you can move one way or another once you get the circuit built. Okay, if you have any questions or you want a copy of these schematics, let me know. I'd be happy to email you the JPEGs. I think that one is only 80K. The little one, this one here, I think is about 75K, something like that. So send me an email if you'd like those schematics, and I'll get them emailed out to you. Okay, thank you for watching. See you in the next video.